This is just me recording myself, and I'm going to talk about static libraries and header files, why we need to create them, and how they help us make our projects simple and easy to use, with the use of less commands, right? So I'll start now. So the use of header files libraries is important because when you have this with the presence of these files, your code is simplified, right? You are not stressed out with having to repeat a series of codes over and over again. So for example, you have a formula. You have a star a, right, plus b plus c, and divided by d, right? So you see this particular command here. So you are saying we want to do something like so there are two values. We have two values. We have these are 5 values: A, E, B, C, and D. Right, and each of them, this is basically what you call a formula, right? Let's say this is a formula, right? And we are giving these are 5 variables, and each of these variables will give a figure, right? A, E, B, C, and D. Right, now imagine you are writing your codes, right? You have to explain that, okay, I have A, E plus B and all of this. And then when you're writing your code, you know that when you declare all your variables, int A, int B, int C, int D, and int E. When you declare all of them, you need to now start saying that result is equal to A star E plus B plus C slash D, right? And then you say print results, and result will print the final output. Now, in that project you just did, you run it, is successful. Now, if you do another project again and you require this formula, right, you have to write it again, right? You have to write int A, int B, int C, int D, and int E, and then you need to say that result is equal to A times A star E plus B plus C slash D, right? So for every time you are doing a different project, right, maybe a different code, you have to always explain to your C language, right, that this is what you want to do. But you see, it's stressful, it's tiring. I mean, if for every code I'm doing I need to do this, then I'll get tired. So is there a way to make it simpler where I can just define I can just define this formula, and I don't have to come back and always keep writing it for my different projects, right? So when I come and I want to just use the same formula again to do another project, I just put in the values I want to put. I just put the values and I get my answer immediately without having to start writing this again, and then int A, int B, int C, the functions and all of that is stressful. So that's where the use of libraries come in, and header files as a user defined header file, right, where you can apply this. And so we'll just go through it and then see what comes out of it. Alright, so to start with, I want to do a simple mathematics equation. So let's say addition, multiplication, and division, right? Addition, multiplication, and division. And so I will create a file. So let's create a file. So I will do vi, and then I'll create let's do one file is, okay, let's do add more and div. Add more div.c is the name of the file. Alright, so here I include stdio.h, right? And then I also include my header file. So this is going to be my header file. I will define it. I will define my own header file and the functions inside of it. But yeah, this is the header file I will use. And in my header file, I want to use function called addition, right? Addition. So addition, and for my addition, I will do something like this: int A, int B, B, right? And then I open this, and then in this other line, what I'll do is I'll say an int results, right? So I've given a variable result, and I'm saying that my results, right, is going to be equal to a, right? A times b, right? A times b plus c. So a times b plus c. Okay, I'm doing addition here. Okay, let's say I'm doing addition. I'll just do a plus b, right? And then this. So let's see, and then I do return dot results as my final output. And then I close this with a curly bracket, right? And so here I'm declaring a function. This function called addition does not exist in stdio.h. Please take note. This function called addition does not exist in stdio.h, right? It only exists, it's going to exist in my header file here, which I will define soon and you will see, right? So that's why I'm including this here, because this function is going to be defined in this header file. And so I declare two variables of integer data types, variable a and variable b. And if you are wondering, why did I not put my value? Why did I just put int a, int b, and then int result? Why did I just put it here and I don't put it here? So when you include your variables in your method, right? This is a method, right? When you build the variables in your method function, there's no need to put it here again. You'll basically be declaring these variables twice, and it will give you an error. So you just declare it once. Once you declare it here, there's no need to declare it here again, right? But if you don't declare it here, right, you just have open bracket, close bracket, but you don't declare it, you will have to come here and declare. You would have to come here and declare it. So that's that. So I'll exit out of this. Alright, so now I've created my file, add more div. Maybe I should have just made it add since I'm only doing addition, but it's fine. So that's my file, right? And so I have this file for addition. Now I want to create my test.h file. Right. Okay, I want to do my test.h file. You see, if I try to compile this file, if I try to compile it, I'll probably get an error telling me that the test.h is not. That's if I compile it with a wall option, right? If I try to compile it with a wall option, probably get oh, so I didn't declare my file. Sorry, I didn't declare my file. GCC. And when I do add more div, right? .c. Alright, you can see. So when you do this, you get an error that says so you don't have this header file declared, right? So I can't compile it. So you declared a header file called test.h, but in your system it doesn't exist. It doesn't exist in your system. It's not present. So there's no such file or directory that has this header file. So I can't do what you want me to do. So you have to do something about it. So that's why before I can compile this, I need to create my test.h file. Right, and my test.h file, we have my function called addition, right? Remember, I said it's addition, right? And so here I will declare and I will say now hashtag ifndef, right? I'll explain what this whole term means. Explain what they mean. Alright, and then I have an int addition, right? And int a and int b, right? Okay, very good. And so I have this. Okay. I also like to do. Let me do int multiplication, right? And then I have int c and int d. All right. So say I also want to do for division. So I do int division. Okay, and then I do int e, and then I do int f. Okay. So say these are all I have. So I have enter array end if. So I have the function called addition, function called multiplication, and a function called division, right? So these are my user defined functions that I'm creating, and each of them have this integer types variables a, b, c, d, e, and f. So now what this says, this tells your program is, it says, so it tells C, says when you are looking through a C program, right? If you see a file called test.h, a header file called test.h, and it is defined, and this test.h file is defined, check the functions with which it is defined with. So addition, but check the functions. If you see the functions, run it successfully. But if you don't see it, just skip and continue moving. Alright? So with that done, now if I try to compile again, now let me explain something to you. So if I compile, right? If I just do gcc compile, right, my file will be successful. So if you do, so gcc is a compilation, is a program for compiling, right? It compiles your codes together. For C language, it compiles it together. Now the idea behind wall, right? So you know that this means is a flag, like an option, right? So everything has an option. So when you do gcc wall and the name of your file, the same way I did it here, gcc wall and the name of your file. What wall does, wall is an option that gives you any error that is wrong with your code. So it helps you write better code, right? It helps you write better code in the sense that if there's an error or a wrong use of a code, right, it will flag it for you and it will tell you no, it's wrong. For example, if you declare a variable that is unused, right, and you just compile that variable, if you just gcc, it's going to compile. So let me give you an example. So if I do gcc add, right, gcc add more, okay, let me do not gcc yet. So if I do vi add more diff diff.c, right, and let's say I just want to create a variable that is not declared, and so I just say int a. I just said int a, right, and that's it. No, not int a, say int e. Yeah, int e, that's it. I mean, what's int e is just something, is no address to anything. I have int a, I have int b, and the both are giving me values for results, right? Results is equal to these two values, right? But int e doesn't exist anywhere, so it has no value. It's basically doing nothing, right? So it's basically something wrong with this. But you see, if I use just gcc to compile that file, right, if I use just this to compile this file, so this is telling me an error message. So cc gcc more let's see. Now this error message will be looked into collect to. It's a different message. Okay, but if you look at this, right, you can see that when I compiled it to just gcc, and this is the only thing that came out, and this error, I'll figure out what it is. I'm not sure what it is, but this is the only error that came out, so this is not even a problem. But you see, when I did gcc one, right, you can see that it's telling me that warning is a function addition, right, in the function called addition, because the function is what? Addition, int addition, that's the function. And it's telling me warning, unused variable e. Right? There's a variable I have that is unused, right? And because of this error, it's not going to compile my file. It's not going to compile it, right? It's not going to compile my file because it's still a variable that is not used. So I still have my add more, but it's not compiled. It's not in a .o extension. It's still a .c because it's not compiled yet. So you need to I need to compile it. I need to, but if I want it to just compile without having that error message, then I just use GCC. Right, so that wall is an option that helps you write better code. So if there's any excess variable that is declared or that is not used, or there's something in your code that is not important or is affecting, wall will help you remove, indicate it so that I can remove it. But if you don't, but that's the idea. It's advised to use wall, right? And a lot of other options, but I'll not go into details with that. So let me remove that from my code. Remove that from my code. So I'm just trying to explain to you how that works. Okay, so I have so you can see it told me in function addition, right? Because my function here is addition, right? So that's why I said in function addition. You take note of things like that. So when I try to compile this again, I don't know what the other issue was. Alright, so I've compiled it now. Alright, so if you look at my code now, you can see that you will see a .o extension, right? This is compiled already. So this format is machine readable. Right? Is in machine language. Machine language is in ones and zeros, right? So this I've converted it to what you call an object code. Object code ends with a .o extension, right? This contains readable codes, right? This is something I wrote in English, right? If I do so, if you want to know the difference between these two, this is human readable. It's in English. It's a high level programming language. This is machine readable. It's a low level language, right? It's ones and zeros. Humans can read it. So if you want to have a better picture, so if I do cat mod, let's see, you can see what I did in my code, right? Include stdio, ints, and all of that, right? Fantastic. Well, now let's do this. Let's try and see if we can read what's in our right. You can see this is just a bunch of gibberish, all sorts of things, just so this one is just giving me the information of the architecture that I was used to build it. It's a 8.1 version architecture, and all of this gibberish code inside of it. It's giving me BSS memory allocation and all of those things that we basically you can't read it anyway. So that's the difference. So this is now converted to object code. The machine understands the code written in this ones and zeros. This is not giving you the exact ones and zeros, right? But it's stored in ones and zeros. So you can read object code, but you can read programming languages, right? Codes, right? In any extension, C, Python, Ruby, C++, Java, and co. Alright, so we've compiled our file. Now, after compiling our file with what the machine understands, we need to archive this file, right, in a library, right? We need to archive the file in a library so that it can be easily accessed when we run our codes, right? The library makes sure that the things we've worked on, right, it's somewhere stored in the system memory, right? A library that can easily be accessed, the same way you have the libraries for your stdio.h and stdlib.h and the rest, right? We also need to have our own libraries that will help during compilation, right? So anytime we declare our function, right, our addition function, it knows what it needs to do, right? So all it needs to do is just that function called addition. It goes to the library that has that information, and it does what it collects that information, right? So we're going to store our object code inside of an archive library. So we'll create an archive library, right? And let's call it maths.a, and then maths.a, that's what we'll call our library, and then we'll put our add more div.o inside of it. So when I ls again, you will see we have our library now, right? We have our library, our .a library, right? Fantastic. So this library now has this stored inside of it, right? It has this stored inside of it. So now we have achieved we've had success in creating a library, right? So with this done, we've done a couple of things. We've created our header file that contains our addition, multiplication, division function, right? We've written our C code, right? This one contains the mathematical operation we want to perform without having to rewrite it all the time. So this already has A plus B and C, right? If you go back again, you see it already has, so it does add just A plus B, right? So this is already a defined operation, so that anytime we declare two variables for A, two values for A, and a value for A and a value for B, it always gives us it adds both values and gives us the result. So it returns the result for us, so we don't have to always come back to write this. We don't have to write this over and over. We have to write A, write B, and this we don't have to write it over again, right? I will store it in our library where it can easily be accessed when it's needed, right? So we can also index it for easy access. And index it for easy access, right? It's good to index it so that the system knows how to easily go about it. All right, and if you use your T, right? If you use your T, you will see the files that are in your library, right? So this tells you the files in your library. So in this math library with the option T, it displays the files, the object codes in your archived library, your static library. All right, now with that done, now we want to now write the code that we need to run. All right, so now let's write. So we now want to do our first project, right? Our first project. Now, just for test run, they're giving us an assignment, right? A project, and they're like, so we need you to add. So just imagine you every day, let's say, just imagine a student who goes to school every day and is always given an assignment to add two numbers every day. Every day is given an assignment to add two numbers, maybe every day or every week. But say he's given an assignment to always add two numbers, right? And it's like, why am I always having to add two numbers? Maybe, and let's say he's a programmer and he's having to write the code every day, right? Because he doesn't know how to do this method we are doing right here, right? So if he knows about this, right, for someone like that, I mean, and there's no need to always write that same thing over and over again. Just run a program that can do that, and it collects two numbers, right? So anytime you bring in two numbers, like your calculator, 2 plus 2, 4, that's really calculated programmed. You just collect two numbers or multiple numbers, right? Depending on the number of values that your user wants to impute. And because he wants to collect two numbers, he just changes the numbers, and he gets his output without having to write the code over and over again, right? So int, we have int addition, right, which is our function. You don't even need to do this if you don't want to do it. You can still use int main, right, as long as you have this, but whichever way it's fine. And when you have this, right, you have int results, right? And then remember we have declared int, we need to declare int results. But you see, we don't have to declare a and b, right? Because we already have a and b declared in our addition function. We already have it declared in this function here, okay, in addition. So there's no need to include it again. If you want to include it, it's fine. It's not a problem. It's not a problem at all. You can include it if you want to include it. But then you see here, we just have this, right? As a result is addition, right? Addition of a and b, right? So now what we just do is what we add two numbers, right? We've said okay, just to help you guys understand better, we said int a, right, and int b, right? And so int a is taking one value, say a plus b. So the first place we can put 7, right, and then let's say 9. All right. So now from this, right, this is int f, right. I'm coming. I'll explain it soon. Um, all right. We give you results. Okay. some results. Okay, alright, I'm sorry. Alright, so now we're seeing that result is equal to addition, right? I will say that we have a plus b, right, is equal to result. So result is the addition of value for a and value for b. So we are saying for this place here, you can see it is int a, comma, int b. So we are saying 7 is for int a, which is a variable, and 9 is for a variable, right? So you see, anytime we run this file, right, we'll get the addition of these numbers gives you 7 plus 9. You just get the exact answer, which is 16. So for every time you run this code, you will always get 16. So you won't need to go and rewrite the whole. You see, I didn't have to go and start writing result is equal to a plus b, int a is this, int b is this. As I said, I don't need to do this here, right? I'm just doing it so you guys can understand. I can remove it now since I've explained what I want to explain, right? It's just to let you know how this works. And so I don't need to start writing int a, int b. No, it's not necessary. It already has the function that I defined, and the function is not in my library. So when I run this execution, when I run this file on execution, right, it accesses the header file and the header file and everything that's in the library that I made that is available to me, the explanation. And so it just prints out. So it sees the addition function. Sees the addition function, and it knows, okay, this is a, this is b, and it already said we should add it together, and it adds them together and prints out the results every time. No need to write anything again. So for any other program I do, it's still the same thing. Fantastic, no stress. All I need to do is change the figure and I'll get my answer. Change the figure, I'll get my answer, and that's all. No problem whatsoever. So I exit this, right? And so now I want to now make this executable. So I want to make this executable, so I compile this and I'll move it to let's see. And then I want to name it test one. If you are going to use the addition, then you need to you need to declare the functions inside your brackets. When you want to use the addition, you can also use write your main, right, and move on, right, so we know what you are dealing with. Okay, so you already have your results and you know what your result is supposed to give you, the addition of two numbers. As once you put those two numbers there, you should be good. Right, that's when we start to compile, right, which is not really a problem at all. GCC, and then we do can use it. You can decide not to use one. It's your choice. I said it's all part of just giving yourself better code, but I'm not trying to write better codes now. Just trying to do an explanation of something so that I can move on. Right, so I want to name this file test run. No mind the initial error. Alright, so this is done. Right, so if you do what I did before, which is int addition, right, then you need to state the conditions, right, the conditions there, right. So that's something you need to take note of. But if you use int and the function that you defined, then if you remember the same way you do your ALX project, and when you have a function that you defined, then you need to also give the values, the prototype declaration, right, or the various data types and the variables that is in that function. But if you're just going to, if you don't want to do that, which I don't think you should do, because the idea of this whole process is so that you avoid rewriting all these things over again, right? So you just do int main, like you saw earlier. If I do example.c, right, you just do int main, right, and open close brackets, and that's it. So int main, and then you do results, because this is already present, so it knows what this is, right? This file here knows what this is, right? Now I've made my file executable. If you see, you can see my file is executable, right? So let's see if it works now. So if I run this, what do I get? You know, it was 9 and 7, right? And we said we are trying to do addition of 9, a plus b. So those are two variables. Okay, awesome. See, so it's telling me, it has given me the output I wanted. So I said the addition of these two numbers gives you 16. Fantastic. So that means that this was a big success, right? Now, you see what this does. Let me show you, explain better. So if I say, okay, you know what, I want to change the value. They said it's giving me another value that I need to work with, right? So there are better ways to do this, right? But I'll explain the other way to do it that's better. So they give me another value. They're giving me a very big number. I mean, just one weird number. So give me about 19.8, 19.8. I mean, what a weird number. And then it just give me 19.9, like just some ridiculous number. I mean, I don't have time to add this thing over and over again. I need to be fast. We need to have a calculator, calculator. All right. So now I've changed my figures. I've changed my figures. Right. So when I run this, it's don't forget. I'll show you something. You know why it's giving me this same value, right? It's because this is already an executable file, right? This is already an executable file that has the numbers 9 and that has these two numbers. That has the number 7 and 9, right? It's already an executable file. So I did not when I changed the code here, it did not overwrite this execute. This is already an executable file. It did not overwrite it. So I need to compile this again and turn it into another kind of executable file with a different name, right? The same way the same way I came here and I used this option to change the name of my file from this to this is the same way I will do the same thing here and change this again, right? I can rewrite my code several times, right? But once I convert it to an executable file, that executable file is fixed, right? Unless you delete it, you can't change anything inside. So you have to go back to your code, rewrite your code, and make it executable again with another name. All right. So now it means I have to do this again. But you see, I changed my numbers already, right? I changed my numbers already. So means I mean, look at the weird numbers I had, very big weird numbers. Calculating those things will be stressful, depending on who is calculating it anyway. So and I want this to be just run. This should just be run, right? So if I ls now, you can see I have two executables. See, the first one that had 7 and 9, and this one that had what, run.exe, right? And so when I do dot, run, what do I get? See, oh, fantastic. See, addition of these two numbers gives me 21,824. Oh, fantastic. Now you see, I no longer need to go through the stress of, that means the thing I did initially, right, which was writing that addition code, right, writing this, right, I don't need to write it over again. I don't need to write it over and over again because it's already there. I've already defined my variable int result. I defined my integer data type and my variable data. So I have my variables and my integer data type, right? And I've defined that I want it to always print a plus b. So once I've given you two variables. So I always give me when I give you two variables, two values, right? Replace those values in place of the variables, right? So a will be the first figure, b will be, if I interchange it, right, and I put b here, a here, right, b here, a here, then the value that I put here will be the first, will be b for b, and the next one will be for a, right? And so I don't need to have to come writing this thing again, and so it saves me a whole ton of stress. So every time I execute this code, I will always get this answer. If I want to change it again, the same thing I did before, go back into this file, and go back to this file. When you come back here, just do what? Change the code, compile it, and convert it to an executable file, and you are good to go. So if I say, let's just run it again. Look at it there, 21,000, right? No stress whatsoever. How do that? Look at it here. 21,000, and we're good. But you see, this is kind of stressful, like. By the way, it's giving me a new line here because I have a new line in my code. So that's why there's an empty line here. Because if you look at the example.c, I gave it a new line. So it's entered new line. But if I delete this, I will have this new line. it will be gone, right? But you see, this is stressful. It means that anytime I want to get a number, I need to always create a different executable file. I probably without, because I'm trying to run a code, I will create like 100 executable file every time. I mean, it doesn't really make any sense. It's stressful. So how can I make it easier? So this is where you now start doing something like scanf, printf scanf, right? So you say impute the first value, right? I put in my first value. You say what's the second value? Put your second value and add it together. So every time you run that program, right? For every time you run that program, it will always give you the desired output you want to get, and you won't have to create this all over again, right? That would be something that maybe we'll do on the group chats for better interaction. Right? I think I already gave a project, a task on that for all of us to try on the group, so you can try to work on that. If you want to know where the question, you can ask me so I can tag you to it. But it will be a good exercise. That's why I don't want to do that one here. I just wanted to explain how you can, your libraries, your files, your libraries, static object files, and all of this work together to make life easy for you as a programmer. Why you need to understand libraries and header files and how they are used and how to apply them. All right, thank you guys. Hopefully this was helpful. Hopefully I can do this another time for something else. Have a good night.